Our next presenter is Dustin Albright. Dustin is an assistant professor of architecture here at Clemson.
That's right.
Assistant.
Yeah.
And I'm very proud of him. He's just won a creativity professorship given out by the College of Architecture, or Art, Architecture, and Humanities in our school. And so he's actually going to be spending some of his time over the next year and understanding how to better teach and creatively teach structures, including steel, wood, concrete, all kinds of things, to our architecture students who basically have to learn all of those kinds of engineering aspects in order to put in place to make and create those beautiful buildings that we love. Like teaching those students how to make a CLT garage.
That's right.
Or this guy. Anyway, Dustin is going to talk about what's going on in trends and outlooks in wood and timber design for us, because I think this is an important part of the excitement about wood.
That's right. Thanks, Pat. Okay, so Pat asked me to put some images together and start to look at, like I said, some of the trends in wood and timber utilization in the building industry. I'm not going to spend as much time talking about light wood construction, but there's a lot going on there. There's some really great resources, whether it's from Woodworks or Rethink Wood or AWC. There's included on your flash drive. There's a presentation, a short paper called Trends in Wood Construction that has some focus on light wood. I'm going to focus a little bit more on mass timber and then show you some of the things that we're up to here at Clemson as well. In the light wood realm, we had enjoyed the presentation on the building codes. For Type 3 construction, you are permitted up to 5 stories of wood, and that can then be also stacked on a non-combustible podium, typically reinforced concrete or precast. And so you're seeing more and more multifamily residential projects with wood and more mid-rise, something larger than your 2 or 3 story variety. But as I said, there are great resources out there for that. So we're going to talk to again show you some new developments, look at some of the things that are being done with mass timber. But I wanted to just start off by kind of rehashing some of the motivators, the things that are fueling these new developments. And so on the one hand, we can talk about the economics of construction. So with more and more of an emphasis on prefabricated assemblies, there's a great economy when it comes to rapid on-site construction. And with these massive timber systems, also there's very strong, very high structural capacities, both in bending and shear, and so you're seeing lots of growing interest, as has been mentioned throughout the afternoon, in these massive timber systems. Constructability, so this is an important thing. So as we talk about massive timber, whether it's CLT or some of the other varieties that I'll show, these are envisioned to be direct competitors with steel and concrete, in particular with precast. And so if you think about the advantages over precast, not only is there the carbon footprint advantage, which has been mentioned, I'll mention it again, but there's also just the ability to work with and modify fairly easily wood construction on site as needed versus precast, that kind of thing. And then that gets into the adaptability, and then the economics of weight. And so you think about there are estimates out there that the massive timber buildings save up to 50% on weight versus precast and other competing systems. So where you save on weight, you're saving on footing and foundation design. It really has kind of a snowballing effect on the economics of the situation. The economics of green that we've learned about today's life cycle analysis and the growing emphasis on embodied energy. Our buildings in the United States, latest estimate, account accounts for 39% of our energy use throughout the country. And we're, over the years, making really great strides in the areas of energy efficiency of usage. So we have more efficient light bulbs, more efficient HVAC systems, you name it, better insulated walls. But there's a growing emphasis on embodied energy, the energy that is embedded in our materials and their harvest and the way that they're shipped to our sites, and then also the construction activities, the energy tied up in construction activities on site. So all of these things are actually propelling the use of wood, whether it's light wood construction or more massive timber applications. And then just the aesthetics and the health benefits. Jeff mentioned this morning some of the humidity regulating benefits. There are other studies done by, for example, FP Innovations up in British Columbia that just look at the appearance of wood and its effect on regulating stress indicators. So there's some good research out there on health benefits related to wood usage in our interiors. And then also these developments and its kind of expanding use of wood and timber systems are enabled by our quality of building codes, which have grown to be more accepting of mid-rise and hopefully eventually high-rise construction. The acceptance of the recognition of CLT and massive timber within Type 4 construction is a considerable development. And then as well, CNC milling technology. So CNC stands for computer numerical controlled. We've had CNC machines for years and years, 3-axis machines. So the 3 axes are X and Y and then up and down. 5-axis machines that are more and more prevalent in the massive timber world have all of those functions as well as a rotational axis in each direction. So you can, without having to take big pieces off the bed, flip them around, and then drill, these machines can do all of that. So the technology is there to do really sophisticated operations from the production standpoint. Some of the sustainability benefits of it, we won't rehash this in depth, but just the renewability of wood as a material, the life cycle assessment and the embodied energy part of that equation, and then the carbon sequestration. So all of these things, again, are motivating, whether it's for years now in Europe and then into North America, in the Northwest in particular, and it's kind of migrating down. This shift back and this resurgence, somebody used the word resurgence earlier, Steve did, of wood and timber construction. The LCA, I won't get into this in depth. There are really great resources through Dovetail. We heard from Jeff this morning. And so the LCA looks at a number of different things. Wood is comparatively strong in many of these areas, in particular global warming potential, and that's related to the embodied energy, as we've learned about. Just for your reference, and in my work as a designer, and I have a dual background in architecture and engineering, I'm looking for the tools that are out there that help me kind of put numbers to these things and categorize the environmental benefits of wood and timber, for example. So there are environmental product declarations. The wood industry is really leading in that arena. So whether it's plywood or OSB or lumber of any given species, you can find EPDs that have been done that kind of give you kind of a quick bullet point look at embodied energy and those sorts of things. Woodworks offers a carbon calculator online. It's a great resource, and then you see some of the others. Tally is an interesting one. This is a plug-in for Revit. Revit is our kind of industry-leading building information modeling software. It's used for design and modeling and producing buildings. And so that was actually developed by an architecture firm in Philadelphia, and it's now out there, and so it's just a really great resource. Okay, so looking at prefab mass timber systems, I want to lay out just some of the terminology. We talked a little bit about cross-laminated timber, but for those that may not know, I expect that most of you do. This technology was developed in Europe in the 90s, and first used, I think, in 93 maybe in Switzerland. There's a big company, big producer in Austria named KLH. And so it's been around. It started to move into North America. And so you're getting the benefits of the cross-lamination, which provides greater dimensional stability for these panels. So it's incredibly strong, incredibly lightweight relative to its competitors like precast. And so it's really exciting. And then things like doors and window openings, all these things can be pre-processed and pre-cut using the kind of the CNC capabilities that we have. So you're looking at a game changer in terms of on-site construction time. So looking again at the advantages, the prefab, the ease of installation, that's shorter on-site construction times with really small crews actually, and we'll look at an example. In those scenarios, CLT becomes a very economical choice for mid-rise projects. Any project that has repeatable units and has that's kind of the embedded economy of producing, repeated wall sections. Prefabrication also provides a measure of really unparalleled quality control, really unparalleled precise tolerances. The bidirectional aspect of CLT makes it capable of larger spans without additional structure. Also, it's very strong in shear, et cetera, et cetera. So the carbon sequestration, we mentioned these things. And then I mentioned it's very lightweight, which by comparison, which allows for reduced sizes on the foundations. That's considerable. That's not to be overlooked in terms of the economics. Challenges, as with any kind of large-scale prefab system, just the coordination and installation, the coordinated installation on site, making sure that you have adequate space for laydown, et cetera. And then a big one is sound isolation between units. And so we'll see in one of the examples that I'll show one kind of common way of providing for sound isolation between floors, whether it's an office structure or between floors in a residential application. I mentioned the CLT handbook. So this is produced by FP Innovations and is available to download for free online. So this is a project, 24 Murray Grove. It's in London. It's an apartment complex, apartment building designed by Wall Thistleton Architects. The CLT panels came from KLH, which also has an office in London, but I think they were produced in Austria for this project. But this was one that really started to make waves internationally and really started to raise the level of interest here in the United States. So you see some images here from the construction, and I'll start to dig into a little bit of the kind of the metrics. So it's 8 stories of CLT framed apartments above, again, a non-combustible first floor, in this case concrete. The 8-story CLT framing was completed in 27 working days with a crew of 4 people, which is really mind-boggling. So this crew of 4 included the crane operator and 3 others that are just sort of maneuvering the panels into place and fastening everything down. So again, super rapid construction with small crews. The panels, as I said, were produced by KLH. So this is an interior image here. Prior to, in this case, most of the interior walls were covered with sheetrock and they kind of go away. So here's some of the sheetrocking process, and then later an image from that same vantage point of the kitchen in this apartment. So this was a project that really made waves, as I said, and raised the international interest. So that's cross-laminated timber in a nutshell. We'll see maybe 1 or 2 other projects here in a moment. Another variation on that, again, it's a massive timber system. Solid wood is nail-laminated timber, so or NLT. And so this is produced, and this is a good diagram. This comes from Structure Craft. Structure Craft is a producer of massive timber products in Canada. And so in this case, rather than gluing and rather than the cross-lamination, you're just you're stacking these edgewise and nailing. So this is a new office building that's being constructed right now in Minneapolis. The architect is Michael Green and Associates. How many of you have heard of Michael Green and Associates? So in the world of mass timber and wood utilization, Michael Green is one of the kind of big advocates out there. It's really doing exciting work. Pat and I had the opportunity to visit with him, his office in British Columbia last year. So this is the T3 office building in Minneapolis. You see a rendering here. This will be a 7-story construction, over 200,000 square feet, using a combination of nail-laminated timber as well as glue-lam. So you see the glue-lam kind of post and beam structure here underneath, and then there's the nail-lam panels for the floors. Now what you'll notice is that these floors are topped with concrete. So there's a concrete finish layer that is, well, it's more than a finish layer really. This works as a composite system, but the concrete in particular is used for sound isolation. So that helps, that adds mass and helps increase both the IIC rating and the STC rating, which are influential for these massive timber applications. So that's IIC is airborne sound translation, and STC is structure-borne sound, so footfall, vibrations, and those kinds of things. So a lot of times what you're seeing with kind of these leading-edge architects working with mass timber are these kind of hybrid uses of these materials for these types of purposes. There's approximately 3,600 cubic meters of wood used in the structure. That equates to around 3,200 tons of carbon sequestered for the life of the building. The timber erection is scheduled to be completed in just 2.5 months, so that's an average of 9 days per story for the timber frame. And then you see some of the other metrics there as far as quantity of panels, and so on and so forth. In this case, most of the wood is beetle kill pine, so it's a good way to reuse that material. Here's an image. This was, if you visit Michael Green's website, they've got snapshots from the construction. So this was February 26th of this year, around 11 o'clock in the morning. So you can see some of the non-combustible construction below, and then they're coming up pretty rapidly with this wood frame construction. So what you don't see are lots and lots of crew. You know, again, it's a light crew and really rapid on-site work. Here's crane operators doing his thing, and then a couple guys here to help guide these into place. So if you look carefully, you can see the nail lam kind of lined up edgewise, and that's how that system works. Another similar system to nail lam. I mean, we all have seen and touched glue lam, beams or rafters, that kind of thing. They're making now, Structure Craft is in particular, glue lam panels, so they work like the nail lam, but they're glued instead with really high strength adhesives. And adhesive technology, that's something that we started to look at here at Clemson as well. Just the fire performance of those things. The adhesive technologies are getting better and better and greener as well to support kind of the larger movement in the industry. So this is a new project ongoing in Portland by a group called Path Architecture. The development's called Carbon 12. And so you see some of this is a snapshot from Path Architecture's website. So they're getting into like really for their clients, and I'm sure for assisting the developer in raising awareness of the environmental benefits of this approach. And so you see in the next image, this is another one from their website where they're describing the life cycle benefits, the carbon benefits of wood, and they're talking about carbon sequestration, the things that we've been learning about today. So this is really a part of the marketing for these types of systems. This is really a part of driving these things, these technologies forward. So that's Carbon 12. This comes from a report from Dovetail Partners. and they borrowed this table from Rethink Wood. Rethink Wood is a really great resource that's sponsored by the Softwood Lumber Council. So this is just a listing of some of the tall timber structures that are already out there or that are going up currently. And so you see, I think Steve mentioned the project at University of British Columbia. I don't know if that one's here in this list, but so you do see Carbon 12 project. It's a 24-story structure being constructed in Austria. I hope to visit that this summer. And so really this is a worldwide thing. It was motivated early on in Europe, but it's really moving to North America. So it's an exciting time to just kind of be in the wood industry, which is pretty interesting. And it's super, super strong. They've done tests and actually compared its capacity to traditional CLT. It's actually stronger in performance. So this is interesting. We'll see where this goes. This was a barn that was constructed by Euclid Timber using the interlocking CLT or ICLT. This is an interesting project. These are a series of Girl Scout cabins that are just outside of Salt Lake City. Award-winning project, really beautiful. This again these were designed by faculty and students at the University of Utah as an application for the interlocking CLT panels. And so you see an interior here. So there's some exciting work, and what I like about this is that it's a kind of a smaller scale, than the tall timber, so it gives you an idea of the range of things, and I'm sure a broader range here in a moment as well. A range of the applications for these kind of newer technologies in wood utilization. So to that point, Pat showed a great video a little earlier from Smartland in Montana. This is another company, Nordic Structures. Nordic is actually a design and engineering company, and they're based in Canada, and so they've done a lot of work with timber bridges, mass timber bridges. I think that this bridge, I couldn't find all the information on it, but I think this is laminated veneer lumber, LVS. This is not, but it's similar properties. Draws on similar technologies. So really great project there. There's another of their bridges. So these things are erected very quickly. This is a smaller scale. This one can be set on the abutments, just similarly to the video that Pat showed, and you're in and out. It's super quick. So again, this is a great application for these technologies. So from Nordic's website, they talk about reduced delivery times, using local sourcing. They're talking about members and system size to the nearest millimeter. So again, those really, really precise tolerances and drawing on current manufacturing technologies. And then skipping down, just the reduction in the project duration. So again, time is money on site. So really fast erection and installation times, no need for heavy equipment. So this is where these things are competitive. Yeah.
What's the preservative for those type of structures?
That's a good question, Pat. Any?
I think that they're not preserved, as we would call it, and if I remember correctly, and I think they are using a covering on them like asphalt or something like that. But I've not seen them in person, so I'm not going to say.
And they're not 3D.
They're not
right, not
3D
conventionally, and then underneath, they're making sure that they're not grounded, and the air can circulate and that kind of thing. The adhesives that they're using are exterior adhesives and have been rated for all those kinds of applications. But that's a good question about the preservative. And then self-weight, we talked about the weight substantially reduced, so on and so forth. So really great competitive advantages for these massive timber bridge systems. This, we saw the video from Smartland. This is from their website, where they're describing being able to span up to 24 feet, carrying fully loaded semi-truck. They're talking about a reduction of up to 50% in their weight. So these things, again, have a ripple effect in terms of the applicability and the viability of these systems in comparison to competing materials and systems. Smart Lamb, continuing Smart Lamb, they're getting into modular systems, modular construction. So they offer these modular shelters for ag applications. Modular loafing sheds, interestingly enough. We saw some of the modular barn structures that Pat showed, just the renderings of. So this is a really interesting group. We've had many opportunities to visit with some of the folks, and they're up to some interesting things. I'm going to have the opportunity, so I mentioned the equine, the farm structures. I'm going to have the opportunity in the fall to work with John Blackburn, who's an alumnus of Clemson, works in Washington, D.C. and designs equine structures all over the United States. This is a prefab barn structure that he's designed and is looking to market. And so this is a combination of dimension lumber and then also some glulam posts and beams for larger spans. So these, they're really exciting applications in the area of ag and equine. I'm looking forward to learning a lot from John this coming fall. Transit is a big area of expansion for these systems. So it's a big time. Wherever you go, I spent some time a couple summers ago in Scandinavia. This is a real train station in just outside of Oslo. So it's everywhere. It's starting to move into the U.S. So this is in Bellevue, Washington, a bus station there, and this is a bit more exotic, but a bus shelter at the University of British Columbia with this kind of interesting honeycomb glulam structure. And then, more and more you're seeing it used, again, with this resurgence, this interest in wood and all of its sustainable benefits. You're seeing it used in park structures more and more. I was just in Virginia helping my mom move, and so this was just down the way from her, a really nice little glulam picnic shelter. So there's lots and lots of opportunities out there. Glulam is something that we're more familiar with versus CLT and some of the more cutting edge systems, but it's all in the realm of mass timber, and there's a range of applications for this stuff. So just really quickly, some of the things that we're working on here at Clemson in these areas, we're looking at cross-laminated timber using southern pine, something that hasn't really been studied extensively as we're working on it. There's some work at Virginia Tech, some work at NC State. We've had a master's student who graduated a couple of years ago that was looking at long span floor systems that would sandwich glulam web members between two flanges of CLT. So that's exciting. There's potential to integrate mechanical and plumbing systems into those cavities. So we've done some pretty extensive testing through his thesis work on this in terms of the shear capacity, the shear transfer from those flanges to the webs. So he looked at both a glued connection as well as a mechanically fastened connection. So that's an interesting area. We're getting ready to be able to do some full-scale tests on these panels. As I mentioned, we've done some fire-related testing and work, looking at the fire capacity of the different adhesives that are commonly used in the industry. And then Pat alluded to some work that we've done recently, more so in the area of light frame construction. So this Simply is the name that we've given to this really innovative plywood framing system. So this was a system we developed for our entry in the U.S. Solar Decathlon, U.S. Department of Energy Solar Decathlon competition. So thinking about, the DOE in this competition is really squarely focused on energy, end usage of energy. But they're not as interested in, what's the embodied energy, what's the energy equation for moving these houses, these kind of modularly built houses from point A to point B, and then kind of moving them around, the modules with cranes on site and all that. So we aim to really rethink and think more holistically about the energy. And so how can we work with a system that is more analogous to inline light wood framing that can be built on site rapidly, leveraging CNC technologies to their greatest advantage with respect to the connection design. So these things go together super fast. And the frame of this house, which we call the Indigo Pine House, was put together entirely by students and faculty, unskilled labor, in 3 shifts, so about a day and a half. We started a dry in from that point. We imagine that this is a flat pack type systems that would come shipped with pictographic instructions, so just like IKEA furniture. So there's actually, we've garnered a lot of interest from industry. That's my timer, so I need to hurry up. In the system, and we're continuing to develop it. So these are examples from the instructions for how this would go together. So everything from the parts and pieces, all the pieces are pre-labeled through the CNC processing, thinking about how many people it would take for different operations, the type of safety equipment that you need. Even have QR links to instructions, YouTube videos of how to do these. So this system is held together without nails or screws. It's really just steel cable ties, and so it's fast, it's reversible, it's non-destructible in terms of its disassembly. We disassembled the entire frame in less than a day, and disassembled and repackaged the entire frame in less than a day. So, again, the benefits of plywood. Let's get through some of these. Some of the joinery that we developed. The crop stop kitchens, one of those structures that Pat had alluded to, one of those was built with the system, the Simply system. This is in Greenville nearby. This is the frame of our competition house, and this south wall going up, and then a view from the interior. The house was only together, after 2 years of work, the house was only together for about 2 weeks out in Irvine, California. But fortunately, we're about to rebuild it down in PD. Clemson has an agriculture research center there, and they want to house more graduate students, so we'll be rebuilding the house. Because it did come down non-destructively. We'll be in August reconstructing that. And then they're interested in a few other little kind of structures. So we've designed these Simply tiny houses that will be built in the coming years to house up to, I think, 16 graduate student researchers there. So there's some exciting work, again, leveraging available technologies, a commitment to using engineered wood products for their kind of sustainable benefits. And then in this case, working with super lightweight, all these pieces you can carry, one person can carry in their hand. So I wanted to give kind of the broad spectrum, the range of the applications, and then give you an idea of what we're working on here at Clemson. Some resources for you. I mentioned Rethink Wood, Woodworks, Dovetail Partners, really great resources through all these websites, white papers that are written on a variety of topics. Such as this is the modern tall wood buildings paper from Dovetail. One book, Solid Wood, as far as case studies. This is a great book by Joe Mayo, who's a practicing architect in the Seattle area. And then a report done by ITAC and the University of Utah recently. Very thorough case study research on the economics of these mass timber structures that are going up around the world. And specifically in North America, this is the solid timber construction paper there. And that's it. So, any questions?
Did you have a grad student hand cut all those joints on the house?
I had a fleet of grad students design all that, but all of that was cut with the CNC cutter. So, we have that whole house exists, as a series of cut files. That it's in version 10, 10.0 or whatever, or 9.0 in terms of the iterations. And so all of that's done. We've worked with two different partners in our region as far as the cutting all of that. And so we're working to study their energy usage and their time, and we're looking at all angles on that kind of thing. But in terms of the cutting, fortunately they weren't there with a jigsaw kind of doing anything. What other questions?
Yeah, CNCs are just the miracle.
Well, and you know, the capabilities are endless. So in addition to just the joinery, the labeling, the components, electrical contractors don't have to wonder where to drill the hole to pass their wire. We have very cleverly designed locations for that can be pre-labeled to distinguish between, you know, such and such wire voltage, such and such, you know. So there's any number of things that you can do, anything that you can dream up that would benefit from kind of pre-design and that prefab process. That's what we're looking at.
That technology, is it coming down price-wise?
Totally, yeah, big time. So for example, our vision, we didn't end up doing this for a number of reasons, and I won't get into that, but our vision was to design all this and then email the cut files out to California. We were working with a partner for a time in Riverside, and we were going to collect all of that there. We weren't able to, we went in a different direction, but there were still some pieces that we made modifications to right up until the competition. And where we were located in California for the semester, myself and the students, was right around the corner from a cabinetry shop. They don't, I mean, this is exotic for what they do. I mean, they're cutting cabinets. But it's the same software, it's the same machinery. So I went around the corner, knocked on their door. They said, yeah, just give me a file type X, you know, and they had it cut by the end of the day. Well, they told me they'd have it cut by the end of the day, but they lagged a little bit. But they had the capability of cutting it up.